Hey, Vlad here, devinside.com. Welcome to another video. The previous video was about partial functions and all the cool things that you can do with them. And I realized that a few parts of this video were a bit complicated, so this one is going to be way more relaxing. So let's get started. As always, we're in the Ubuntu virtual machine and we have Sublime on the left and we have the regular terminal on the right, which runs SBT, which runs our code every time we save the file. Okay, so today we'll focus on the kinds of patterns. So remember in the previous video, the partial functions, we had something like case and then something in there and then an arrow to the right. So today we're talking about everything that you can put in between the case keyword and the arrow. Now, before we even begin discussing pattern matching, what you need to understand that 99% of pattern matching is merely syntactic sugar for a bunch of if expressions, type checks, typecasts, and most importantly, calls to the equals method, or the way you write in Scala, the double equals symbol. So keep it in the back of your head that pattern matching is a tool primarily for data structures and not for objects. And I already made a video about the difference between data structures and objects, so you might want to check it out. So the first example is going to be a method, and we're actually going to stay within this method for the entire video. We're going to have a method that takes some sort of input, right, and produces some sort of output, and in this case it's going to be any, and we're going to talk about this in a second. So we're going to have a simple pattern match over here, and the first pattern kind that we're going to learn about is the variable pattern. So you're going to have a variable here, you can name it however you want. I'm just going to call it variable, but you can do whatever you want over here, right? So let's say variable and then an arrow to the right, and we're just going to return variable, right? Because we can return whatever we want, right? We're going to return any. So let's just throw a few things at it. So that's going to have println method 1, let's give it a 2, let's give it a true, let's give it a false, let's give it a hi as a string, and let's also give it a character C, right, as a character. So let's compile this. So as you can see, a variable pattern matches everything, right? So whatever comes in, you just give it a name and you can use it on the right hand side as with a regular function, right? And the next thing that we're going to do is we're going to talk about overloading. So function overloading is a concept where you can have a slightly different signature of the method, but the name will be the same. So if I copy that and I paste it over here, and I'm going to have an integer over here, then the first thing what's going to happen is that it's not going to compile, because overloading is not enabled, or is not a valid Scala code inside of defs, right? So we're inside of the def code over here, so we can't have it over here. So what we need to do is we need to move them out. So we're going to move them out like this. Okay, let's see what happens. So we don't really see which one is being called. So let's use some string interpolation over here, and we're going to say any variable like that. And let me just copy, oh, sorry, press something else. All right, so let me just copy that, put it over here, and put an int over here so that we can see which one is called. All right, so every time we're passing an integer, this one, 1, and 2, and also the one with a character, it actually calls this one. I'm just showing this to you because I want you to understand that the Scala compiler itself uses something like a pattern matching to match on the signature of the method, right, over here. So this is the signature of the method, right? And it uses pattern matching to determine which one are you calling, right? And the next thing that we're going to do is I'm going to show you that the result type is not part of the signature, right? Since we're already talking about that, I guess let me do this. It doesn't actually really matter because it's not going to compile anyway. So let's do this. Yeah, so we have way too many errors. Let's just do that. All right, so it's going to say, okay, this is something else. Hold up. Yeah, it wants us to return a boolean here, so we can't return a string. So we just need to do true, because that's not what I want to show you. Yeah, this is what I want to show you. So method called method is defined twice. The completed method was defined at line 10 over here, and yeah, that's it, 1 error found. So this is all you need to know about overloading. It can be inside of a def, and the result type is not a part of the signature. So the next thing that we're going to do is we're going to move it back down over here, like this. I'm gonna remove overloading because I just wanted to show it to you. We're gonna do we're gonna have like a bunch of information surrounding the pattern matching topic. Let's see, let's enable that. Okay, so the next thing that I want to show you is that pattern matching doesn't have to start at any, right? So we can start at, actually let me first show you that you can also specify the result type of the method as you were doing before, and this would mean that every case that you have in your partial function, right, in your pattern match, it has to return a string, right? So you can't return something else. Like for example, if we try to return a I don't know, an integer, 1, 2, 3, for example, it's not going to compile because it's going to say, hey, I was expecting a string, but you're giving me an integer. I'm showing you this just to show you what's going to happen if you return a unit, right? Because everything is can be converted to a unit, and one day we're going to talk exactly about what is happening behind the scenes, why an integer why we can make an integer look like a unit, for example, but not for today. So as of right now, we're just getting a warning that a pure expression does nothing in statement position, but we can still do, print line 1, 2, 3, right? So now we're actually producing a unit, okay? And I'm showing you this just to show that if what's resulting from a pattern match is unit, then there's a special syntax that and if you don't want to produce anything, right, then you can just leave it out. So and this is also valid syntax, right? So on the right hand side, it's basically the same as just producing an empty unit, so to say. Now this is so far all we needed to know about the things that are surrounding pattern matching. So we're just going to get back to pattern matching itself. So we're going to get back to variable, and because we're mostly going to use this method, I'm also going to have a method called show, which is also going to get the input of any, and it will produce a unit, and we'll just call println for us. So it's just going to call println method was the input, right? So now over here, everywhere where we say println method, I can just say show, and at the end of the line I can remove this, right? So this is what we have now. So the next pattern that we're going to have is the constant pattern. So this was a variable. Basically you can just give it any name you want, but it can also match on the constant, right? So I'm just going to duplicate that, and I'm going to say that we're going to pattern match on 2, right? So this is the 2, and now on the right hand side there is no variable, obviously, so all we can use on the right hand side is the 2, for example. Let's see what's going to happen here. So you don't actually see the difference, but if I comment out this one, then it's going to throw an exception because it can't match the 1. But if I comment that out, then at least we're going to see the 2, right? And then this one is going to throw an exception. We already learned about this in the previous video, right? The partial functions, they throw an exception if you don't have a default case, and we do have a default case over here, right? Because as we said before, the variable pattern matches everything, right? So I'm just going to do instead of variable, I'm just going to say I'm here, right? So we're going to see the 2, and we're going to see a bunch of I'm here's for this one, and this one, this one, this one, and this one. Yet another kind of pattern is the so-called wildcard pattern. So if you don't need the name over here, like over here, we're actually not using the variable, then we can just use a regular underscore, right? Because we just want to catch like the catch-all case, right? But we don't need the variable, right? So we can just use an underscore, as in many other places in Scala where you don't need the name of the variable, you just use an underscore. And as always, you can't return the underscore here, right? Because that's just invalid. You can use the underscore sort of only once, right? And as you will see by the end of this video, and pattern matching is a very flexible thing, so you'll be able to compose patterns together, which means that sometimes there are multiple ways to accomplish the same thing. For example, over here, if we go for variable and we return the variable is the same thing as the input, right? So we can also return the input, and the result is going to be exactly the same, right? And we can use the wildcat pattern over here, and the result is going to be exactly the same. Many ways to do the same thing. The next thing, I'm not sure if I mentioned this in my previous video, I hope I did, because it's very important. The order of the matches matters, right? So if we do this, for example, if we just switch them, then this will match everything, right? Anything that comes in, it will match it. So this code will never run. And in fact, if we save it, Scala will tell us it's a warning, right? It compiles, but at least we get a warning. Patterns after a variable pattern cannot match. And you see Scala language specification, paragraph something, which explains exactly this. And then it says unreachable code over here, right? Unreachable code due to a variable pattern on line 12, right? So it doesn't even recognize that this is a wildcard pattern, because for it for the Scala compiler, it's the same thing as a variable pattern, right? It's just that we don't need to use the name, so the warning is going to be exactly the same. Also, if we switch them back, right, if we do this, right, and then we copy that again, and we're gonna have this, right? This is going to be a very similar thing, right? It's gonna say patterns after variable pattern cannot match, right? So this is a variable pattern. Anything after that cannot match. Doesn't really matter what it is. Okay, let me remove that. We're back to our regular example. Okay, so as of right now, we've seen the constant patterns, we've seen the wildcard patterns, and we've seen we've seen the variable patterns and the wildcard patterns, which is basically the same thing, right? A common beginner mistake is how to distinguish constant patterns from variable patterns. And here's an example. So let's say that we're gonna have a 1, right? So we should be able to write a 1 over here, right? So we should be able to say, you know, case 1, then just return 1. But Scala has no way to distinguish this thing from this thing, because you can, you know, if you're using a variable pattern, you can give it whatever name you want. So it thinks that you're just introducing another variable, right? So let's see what's going to happen. So first of all, we're going to get a warning, right? The same warning. And we see our 1, 2. It's kind of hard to see what we actually see. So let's do matched 1. Yeah, let's do this. Yeah, so as you can see, like all of them, except for the two matched here, all of the others, they actually matched this one, even though it's not the one. So the way to solve this is by explicitly telling the Scala compiler that what you want to use is a constant pattern. But before I want to show you this, I want to show you a better example to understand what is actually happening. So let me comment all of this out. So what's happening is a typical name shadowing. So if you have val x equals 1, right, and you print line x, then you see your 1. However, if you have a different scope over here, right, and in that scope you have another val, you're going to have val x equals 2. So this 2 shadows the other x, right? So this x shadows this x. So if you do a print line x over here, then in this environment, again, the environment model of computation kicks in. Remember the videos that I made about this. This is a typical name shadowing. This is exactly what's happening over here. So you're just shadowing the name of this one, right? So the way you tell to the Scala compiler that you know what's going on and that you don't want to use the variable pattern is by either using backticks. So do this, right, like this over here. And then it knows exactly what do you mean, right? So only the first one actually matched 1 now, right? And by the way, this is a Scala thing. If you have a variable, you can call it however you want, right? But you can't have, for example, a space, right? So you can't have a variable like this, right? It's gonna say, hey, you know, something is weird, illegal start of a simple pattern. But if you surround a variable with backticks, then Scala will actually know, okay, whatever is inside of this thing is an identifier, right? So now we will able to actually use it in the pattern match as well, right? So in fact, like, so this is actually what's happening every time you create a variable, right? So Scala allows you to create it without backticks if you know, you follow the Scala language specification, right? So whatever is allowed. But in fact, behind the scenes, the compiler always creates, you know, always adds those backticks for itself. So we can actually do this and say matched the 10, right? So if we do show 10 somewhere, then it will actually match this one, right? Which is kind of cool. Let me remove that one. Let me remove that one. Remove that one. That was just like a sidebar. Show a 10. Okay, so we're back at our example. And by the way, so because of this, like if you wanna use it on the actual, you know, on the right hand side, you can do this. You can say this one, right? And then you just use the backtick. So you use it basically exactly the way it's defined, right? So again, the Scala compiler doesn't really care if you have it like this or if you have it like this. But as of right now, you won't be able to say you won't be able to say show 1 like this, because oh yeah, you are actually able to do. So this is exactly the same thing, which is kind of cool. Right, so you can use it like this. And another way to introduce a constant pattern instead of the variable pattern is by using a capital, right? A capital letter. So if you started with uppercase 1 like this, then it will still match, right? So it says this one, right? So it doesn't match the variable pattern. And because now you don't have those weird backticks, you can actually have this, and you will actually have proper syntax highlighting in Sublime. The only exception to this rule is null, right? So if I'm just going to remove this over here, and I'm going to go here, I'm going to say case null, just return null, like this. And let me comment out all of these, right? So I'm gonna say show null, sorry, show now. So now even if we have the variable pattern, variable, I'm just gonna say matched, what's happening, matched variable, right? This one will match and not the other one, right? So this is the only exception. Null is the only thing that can be called with a lowercase and still be used as a constant pattern and not as a variable pattern. And that's all I'm gonna say about null. Let's go back to this, let's go back to that, and let's go back to this and that. All right, so the next thing that you need to know that this only works with a so-called stable identifier, which means it only works with a val, it works with a lazy val, right? And it works with an object, right? So if this was an object, let's say, I mean, I can't do object equals something, right? So let's say we already have an object main, right? So let's try this. Let's do case, right? What's happening? Case main. So we're going to use main as a constant, right? Because it's called with a capital, right? So we can use it. Main. I'm going to say, we're just going to use main, right? So now over here, in fact, I probably should like remove them like that. So now we're going to go and we're going to say show main or show this. Both of them, they will match this. And as I already said, you can't have a def over here, right? Because it's not a stable identifier. Then it says hey, stable identifier required. And the same thing with a var. You can't have that, right? So val is okay, lazy val is okay, objects are okay, and what's also okay is if you have it nested in other objects, right? So if we're going to say over here, so we're going to have an object top, object, I don't know, sub, right? And we're going to have val1 over here equals 1. Then we can, over here, we can do top dot sub dot 1, and it's going to work. And over here, we can do the same thing, top dot sub dot 1, like this. Right, so this also works. Oh, we don't have them. We don't have it over there. Right, let's do. You know what? Let's just do one. Let's just do one, and let's just do one like this. I'm sorry, it's capital. Let's do one, and let's do top dot sub dot 1. Right, because it's all the same value, so they all should match 1. And by the way, as a total sidebar, you can use an object to override a def. I'm going to have a super tiny example here, and this has nothing to do with pattern matching. It's just something that just jumped to my head. So if you have a trait like database, for example, data database, and then you have a service, right? And the service uses a database, right? And over here you have a class, which is a service implementation, right? So it extends service, right? So now we have to implement the database, right? And what we can do is we can do, I'm just going to use override because I'm used to it. Override def db database equals, and now we can use an anonymous class database like this over here, right? So this is an anonymous class, and what I'm going to show you is that it also works with a val, right? It also works with a lazy val. And it also works with an object. I'm gonna do the object on a separate line so that you see the similarity. You can say override object def, and instead of the equal sign, you're gonna say extends, and you're gonna do database like this. And you don't need the curly braces here because now it's not an anonymous class; it's actually a named class. But in reality, the database will have some methods, so you're gonna end up having the curly braces as well, and implementing it. That's all. Let's go back to actually pattern matching. Right, there we go. Okay, so as of right now, again, we know the constant patterns like this or like this or like this. We know the variable patterns and basically the wildcard patterns, which are very similar to the variable patterns. Another thing that you need to know about pattern matching, it's not a pattern kind, it's just another syntax that you can use, is that whenever you have a pattern, right, and a pattern is everything that is between the case and between the arrow, you can bind it to a name, right? So everywhere here, you can just create a name. You can say name at, and I think it's going to work even for this one. Yeah, even for this one, which is, as I always said, it's a very flexible feature, so sometimes it doesn't actually make sense. So now over here, you can use input, you can use variable, you can use name, it's all the same. So what it allows you to do is that if the pattern matches, right, for example, this 2, if it matches, let me enable this over here, Let me enable this one, right? So if it matches, then you can use the variable called name on the right hand side of the arrow. So for example, over here, so it matches the two, and it uses the two over here. Over here, we can just use the name. It just exists on the right hand side now, which allows us to do, instead of doing this on the right hand side, we can just use the name, right? You can just use the name, and it's going to say still the same, this one. Okay, and the next thing that we're going to do is the type pattern. So we have constant, variable, and the wildcards, and now we also have this name at thingy, and the other pattern kind is matching on the type, right? So we're gonna have over here, we're gonna say case, we can do whatever we want over here, and we're just gonna make sure that the type is a boolean. Then we're gonna say, matched a boolean, right? So these true and false should be caught by this one now. And again, the entire pattern can be assigned, can be bound to a name, right? So we can have a name at, and now because it's a slightly complicated pattern, we need to use parentheses over here, right? So now we can say match the boolean name, and we need to use string interpolation over here. So it's going to say match the boolean, but now it's going to say true and false. And for this particular one, we don't actually need this, because as you can see, there's a wildcard pattern over here. We can actually use the name over here if we wanted to, and now we actually don't need this whole thing, right? But if we actually did use it, right, we can literally use both, right? So we can do name and, for example, right? So we can do name here and it's a very flexible feature, as I already mentioned, right? So you can combine it as however you want, right? So it's exactly the same way value: true, true, false, false. The next part is going to be a little bit confusing. So we have an object main, for example, right? What is the type of main? For example, can you do something like, instead of name at, can you do name colon? And it's going to say, well, the type main doesn't exist. It's because the type of main, or the type of every object, is main dot type, right? And this is a little bit ugly, right? But actually, we're not trying to match on it. Let's do show main, or let's just show this, right? Let me remove the others over here, and it's gonna say, yeah, this one, or you can use name. Doesn't really matter. Okay, so the next part is going to be a little bit confusing. So first of all, this is not really common to match on object like this, right? Why would you do this, right? Because you can just say case main. Why would you do this ugliness? But if you wanted to, for some weird reason, there is a cool pattern for something like this. So what we're gonna have is, we're gonna have an object stuff over here, and we're gonna put everything into the stuff. So we're gonna have an object. We're gonna have an object called we're gonna call it fancy, right? So if you keep it like this, then over here we're gonna have stuff fancy dot type, and this is not what we want. So the idea is to have the object itself be called with an underscore, and then just delegate to it. So we're gonna have a type alias, which is called fancy. It's just gonna be fancy dot type, right? And we're gonna have a val, and we're going to call it fancy, and it's going to be of type fancy, and the value is going to be fancy. So now what we can do over here is, why fence? No, not fence, fancy. There we go. So what we can do over here is, oh yeah, I removed this other one. Come on, gone. There we go. So let me do that. Let me go here. So now we can do case stuff dot fancy. I'm gonna say first line, right? Now on the second line, we can say name at stuff fancy, and on the third line, we can also say name stuff fancy, like this, right? Third line. Okay, now they're all basically the same and unreachable code and whatever. So over here, we're gonna say show stuff dot fancy, like this, right? And let's see, so let's comment out this one. Okay, the first one matches, the second one matches, right? And the third one also matches, right? Which is kind of cool, but it leads to a little bit of confusion, right? Look what's going to happen. So look, for example, this one and this one, they look, very much the same. If I do this, for example, the only difference is at, and the difference over here is colon. Look what's going to happen with a boolean, right? So if we had case name at boolean, name, and we're going to have a colon, right? It's not the same thing. So I'm going to say name over here. I'm just going to say the type, right? Let me remove this one. So for this one, it doesn't really matter, right? Because we use this other trick. But for this one, look what's going to happen. I'm going to do true. It matches the type, but it doesn't match the name. What's happening over here? Well, because this pattern is only going to match the companion object for Boolean, right? So if I pass in a Boolean here, right, the actual companion object for Boolean, the Boolean in Scala has a companion object, then it will match, right? So be very careful when you use the type pattern and when you just use this binding to the name. And as a tiny sidebar, it would be kind of cool if we could make this this object, if we could make it private. Right, but we can't because we were also exposing it over here. We can't do private, or we can't do private this. And by the way, if we were actually printing it out, right? So let's say over here, if we were printing it out, let's see, name like this, and let's use it. Where are we using it? Did I remove it? I removed it. All right, so let's gonna do show stuff.fancy. Fancy, blah, blah, blah. Oh yeah, I still have this private thing. I did not mean to leave it there. All right, so this is how it looks like. What you can do is, if you prepend it with case, right, then the name is going to look like _fancy, but this is not what you want, right? So what you can do is you can override the toString method. You can do override def toString, which returns a string, and you can just say fancy, and then it's going to look even more confusing. All right, so we're done with this fancy thing. And while I remove all of the stuff, I'm also going to recap everything that we have done. So we know the constant patterns now, and we know the variable patterns, and we know the wildcard patterns, and we know those name bindings, and now we also know the type patterns. And all these patterns so far, they are what I call primitive patterns, right? I don't think anyone else calls them like this, but I do. So I call them primitive because everything else from now on is basically a combination of these. And now this is where the fun begins. So let me just see if everything compiles. Let me see if I have everything that I need and if I have removed everything that I don't need. All right, so what we're going to have is a simple class person. Class person is going to have a name, and it's going to have an age, and it's going to have one member is adult. It's going to be a Boolean, and it's just going to say if the person is older than 18, right? So what we're going to have now is we're going to have a type pattern, right? So we're going to have person of type person, and on the right hand side we're just going to see person is a adult, right? And let's create a person now. Let's create Alice. Let's create Alice. Alice is a new person. Alice is a new person. She just did yoga and it changed her life. She's a new person now. So age is going to be 27. And let's see if we actually use Alice over here. All right, so show Alice is going to say, okay, she's an adult, and if she was 15, then she wouldn't be an adult, right? Okay, let's go back to 27. So we're about to talk about the so-called constructor patterns, but before going there, let me introduce you to the so-called pattern matching guards, or pattern guards, or just guards, which are simple if expressions that you can put over here, right? So after the pattern and before the, before the arrow to the right, right? And when you have a guard, in contrast to a regular if expression, you don't need parentheses, right? Because the compiler can distinguish where the compiler can know where the expression will end, because it's going to follow with an arrow. So we can do it here. I'm going to have another pattern, right? So I'm going to have over here, if person is adult, then let me actually collapse that line so that it so that it fits into my tiny screen, right? So if person is adult, then just do guard, and we're going to see person dot is adult, just for fun, right? So if it's an adult, then it's going to match this one, right? Because there's a guard over here. And by the way, you need guards when a pattern is not enough to express what you want to match on, right? And if we do 15, then it's not going to match this one. It will just match this one and just just return false. Okay. All right. So I'm not sure if you noticed this, but we're not dealing with a person as if it was a data structure, right? And pattern matching is for data structures. So we're treating a person as an object because it hides the data, right, and exposes behavior. So we could actually mix them, but as I already mentioned in the video about the difference between data structures and objects, it's actually not a really good idea. But for now, for education purposes, we can actually expose name and age. Let's just expose name. It doesn't matter really now. Let's expose name and let's expose age. So for example, over here, if we match on a person, we can also I don't know, just do this person name, right? So as a reminder, if it was not a val over here, we wouldn't be able to access name. It will say value name is not a member of person, right? So it's basically a private val, right? Let's go back to this. Remember that it's not a good idea to mix data structures and objects, because now instead of starting to look like a data structure, but we still don't have structural equality. To demonstrate that, let me move Alice to the top. Let's take Alice, let's move her to the top over here, and let's try to use the constant pattern over here, right? We already know that we can use the backticks like this if you want to use it as a constant pattern. I'm going to say over here, not structural equality. So if you use reference equality, right, so if you use exactly the same instance of Alice, then this thing will match. However, if we just copy paste Alice, right, so if I just copy that, right, and I go in here, I'm going to say show, and I'm going to insert this over here, it's going to say Alice, right? So it did not match this one, right? So let me remove this. It did not match this one. The structural equality is gone because even though you try to mimic the data structure, it's actually not a data structure, it's an object, which is why it's really, really important. Because remember, in the beginning of this video, I said pattern matching is just a fancy syntax over if expressions, over typecasts, type checks, and most importantly, over equals, right? So it's being checked for equality over here. There's nothing fancy behind this. Behind this, all it's doing is if Alice equals to input, right? That's all it's doing behind the scenes. All right, that's very, very important. All this is fixed if you're actually treating a person as a data structure. So if we just prepend it with a case over here, and a data structure should always be marked as final, right? Then first of all, we don't need the vowels over here, right? And because it's a data structure, we don't even need the new over here and the new over here. And now it actually is structural equality, because now in both cases it will yield true, which is exactly what we want. All right, let's finally start talking about the constructor patterns. Let me move Alice back down. Let me move Alice back down over here, and we're gonna have show Alice, and we're gonna remove this, and we're gonna remove that, and we're not gonna have this over here. So back to our code, which is now much smaller. We're going to have a video soon related to case classes alone, where we're going to talk about them in depth. All you need to know right now is that when you prepend a class with case, then a bunch of code is being generated, and part of this code allows you to pattern match on case classes, right? So what you can do now is, let me actually remove all the others like this. So what you can do now is you can say, for example, p at, and then your pattern becomes a so-called constructor pattern. So the same way as you would construct a person, the same way you would pattern match on it, you would say person, right? And then you can use variables, right? And a for name and age. And I prepared a fancy string over here. So we're gonna have matched $n or money sign, who is years old. This is the toString implementation, which also comes from the fact that it's a case class, and we're going to use $p dot toString over here, finish the string, and strip the margin, and let's see what's going to happen. And by the way, so it says matched. Oh, come on, matched. All right, so it says matched Alice, who is 15 years old. This is the toString implementation, person Alice 15. Remember, if it was a normal class, then the toString would look really weird. And we're going to talk about this in the video about case classes, okay? By the way, one thing about a string interpolation over here is that you don't need to say toString over here, right? So you can just use p, and it will be automatically converted into a string, as you can see over here. And now, because it's just a simple variable, you don't even need this, right? So what we're using here is variables, right? So you can use, you can say person here, person, So the only thing that you can't rename is this, right? But you can use whatever you want over here. In fact, you can call it exactly as they define, right? So look, this is why it's called the constructor pattern, because this is exactly how you would construct a person, right? If I mean over here I'm using name and age like this, but if I would inline it, right, then it would look like this, Alice 15, right? So this is very close to this. Okay, let me remove this real quick. Like this. Okay, so oh yeah, so now we need to use name, and now we need to use age over here, which is really beautiful. Okay, now this looks really cool. It's starting to look really fancy, but you have yet to witness the actual power of pattern matching, which comes from nesting the patterns. So what you have here is just a variable pattern, right? But you can go all crazy with it, right? You can use a type pattern, for example, a string, which is useless in this case because every person, the name of every person is going to be a string anyway, but still, you just can, and you can do age at 17, and you can just keep going like this. It's crazy, right? So it's not going to match now because it's 15, but if we go for 17 like this, for 17 like this, now it's going to match, and you can just keep going with this, right? For example, you could say you can add a guard, and because it's not going to fit over here, I'm just going to move this arrow down, and I'm going to say over here, if name to lowercase starts with a, right? So this is not pattern matching anymore, right? We're just using a guard, and we're using regular methods that are defined on the string, right? So we can have a string, we can convert it to lowercase, and we can start if it starts with a lowercase a, right? And I already have an arrow over here, so let's see it like this. I'm just gonna separate the whole, look at this gigantic thing now, right? Just imagine how painful would it be to write this thing in a language like Java, for example, which does not have pattern matching, right? You will have a bunch of if expressions, a bunch of typecasts, a bunch of type checks. It's going to be crazy, right? So this is the true power of pattern matching. This is why people fall in love with pattern matching. They just want to use it all day long. But remember, it's just a tool, so make sure that you actually have a use case for it before you use it. The next thing that we're going to talk about is tuples, or tuples. I still don't know how to pronounce them. So what you need to realize that every tuple is actually a case class. Let me show you. So this is the Scala API for tuple2 in this case. Look, it's a final case class, right? So let's go back. So this means that if we had two people, right? Let me actually copy Alice, and let me convert Alice into Bob. A little bit of transgender stuff here. We're gonna have Bob, and Bob is gonna be 19, right? So we can create a tuple now, right? So tuple or tuple, tuple2, because it's a case class, we don't need the new keyword, right? We're gonna have an Alice, and we're gonna have Bob, and we're gonna use a tuple over here, right? So now what we can do is we can use the constructor pattern to destructure it, right? So we're gonna have a tuple2 over here. We're gonna say AB or Alice Bob, or doesn't actually really matter. Let's use first, second, right, over here, and we're just gonna do received first and second over here, right? And it should match, right? So it's going to say received person Alice and person B, person Bob. You can also do type patterns. As I said, you can combine this like crazy, right? Person. I hope you remember that, because tuples are so useful and very common. There's a special syntax for constructing them like this, right? So it's still a tuple2, so it's still going to match over there, and we can also inline them. Right, so if we inline it, now it looks a bit weird, and for a very long time it was possible to, if you have like a situation like this where you're passing a tuple into a method and you end up like this, and you can remove one of those parentheses, and in fact right now it's still going to work, right? But if you pass a special compiler flag to Scala, in fact let's actually do this. Let's go to the build file over here, and I have a Scala C option deprecation. Let's not have a deprecation here. Let's in fact let's actually leave it. I'm sure we're going to use it for something. So we're going to have sequence here of all the compiler flags like this. So what I want to show you is what happens if we pass in -x lint. I believe it's written like this. Yeah, it's written like this, right? So now if we reload the project and we start running again, it's going to say adapting argument list by creating a two-tuple. This may not be what you want. So it basically warns you that, a bunch of developers, developers were running into accidental issues like this all the time. So I wouldn't be surprised if this was even deprecated in the future. Anyway, let's go back to proper syntax over here. What I'm going to show you now is that you don't have to use the constructor pattern for tuples. You can actually use, the same way as there is a special syntax for constructing tuples, there is also a special syntax for pattern matching on tuples, right? So you can just remove tuple 2 over here and it's still going to match, right? So this is called a tuple pattern. So as of right now, we have constant patterns, variable patterns, wildcard patterns, we have guards, we have the binding of the names with at, and now we also have the tuple patterns. And as I already mentioned, you can nest this like crazy, right? For example, you can copy paste this, right, which is Alice, and now instead of this, right, you can say at and this whole thing, right, and it's still gonna match, right, because it's still exactly the same pattern. In fact, let me maybe do this so that the whole thing fits, right, like this. Or you can do, let me actually copy that. Second one, and what's Bob? Bob is 19. You can use age 19 or you can just use 19. You can just do that. You can say that you don't care about the name. You can do like all the crazy things, right, and it will match. The thing about guards is that if you wanted to copy paste this guard over here, then you can't put it over here, right? The guard has to be after the pattern, which ends over here, by the way, right? So the guard always has to be here. So you can still put it, right? But it has to be there for the whole thing. So in this case, it's gonna match this one. Let's call it Alice name, right? Like this, right? So now it's still gonna match, which is crazy. I can't imagine writing something like this in Java. All right, so I have a section prepared for the so-called regular expressions, but first of all, regular expressions are not really a beginner topic, and secondly, I don't want this video to be longer than an hour, and we're getting very close already. So what I'm going to do is I'm going to skip this, and we're going to talk about this some other time, right? So what we are going to talk about is collections, even though we haven't talked about collections in this playlist yet, but you have a so-called kind of pattern which is called sequence patterns, which allows you to pattern match on collections. So what we're going to do is I'm going to remove everything here, as always, case variable. I'm going to remove Alice and Bob, and we're going to do show one, right? And we're not going to need person. All right. So because we haven't talked about collections yet on this entire playlist, I'm just gonna give you a small crash course. So there are three very important types in the Scala collection, Scala standard library. It's sets, sequences, and maps. And for today, only sequences matter. But in order to explain sequences, it's always better to always explain sets because they're sort of diametrically opposed to each other. So what's a set? A set is a collection of elements with only two properties. The first property is that there are no duplicates, and the second property is that there is no order, right? And this also is a hint for you that sets are supposed to be used with data structures and not with objects, right? Because it has to filter out the duplicates somehow. Well, how is it going to do it? Well, it's going to do it based on the implementation of the equals method, right? So let's just have a bunch of examples before I explain sequences, right? So we're going to have a set of 1, 2, 3 over here. I'm just going to print it out real quick. It says, okay, show, oh yeah, so now because we have this xlength parameter, it gives us a bunch of useful information. I usually don't use flags like this in my tutorials because of this, but in production, like at work, I actually use it. So for now, let's just comment this out like this, and let's reload because I don't want this to disturb us, and let's go back to running, and we have our set was 1, 2, 3. So this is how a set looks like, and again, the order doesn't matter, right? So we have 3, 2, 3, 2, 1 over here, and we're gonna have also 2, 2, 2, 1, 1, 3. So this one says basically no duplicates, right? And we're gonna have a print line over here, so you see the duplicates are gone, and we're gonna do a print line set of 1, 2, 3. Is it the same as set of 3, 2, 1? And it's gonna say yes. And over here we're gonna do is 3, 2, 1, is it the same as this thing? And it should also say yes, right? Because again, the order doesn't matter, and the duplicates don't matter, right? The duplicates get filtered out. The next thing I'm going to show you is how to create empty ones. There are two ways. You can do set int and just do that, or you can do set dot empty and then you specify the type int, and now you don't need these, right? So you can do that. And the next thing I'm going to show you is that these are absolutely equivalent. So we're going to say print line, and we're going to copy this one over here. And is it equal to this one? Yes, it is. Right. So let's now talk about sequences. So the sequences are sort of diametrically opposed. The order actually does matter, and there can be duplicates, which is why it's absolutely fine to use objects with sequences. So what I'm going to do now is I'm going to do another row of hyphens. So we're going to have a hyphen multiplied with 50, and I'm going to copy paste all of this, right? Paste it over here, and now instead of sets, we're going to use sequences, right? So only one letter is different, right? So for sequences, you have 1, 2, 3, 3, 2, 1. The duplicates are being capped, right? And that's why those sequences are not the same, right? For example, this one, the order matters, and the duplicates, they also matter. You construct the empty sequences the same way, but by the way, notice that the toString implementation is a list, because seek. So notice that we're not doing new seek, right? So we're just calling a factory method on the sequence companion object, and by default it constructs a so-called list, which is something that we're going to talk about in in the video about collections when the type comes. Right, so this is all you need to know about sets and about sequences, and in fact, all we need to do now is we need to talk only about pattern matching on sequences, because you can't pattern match on sets. So I'm going to remove all of this again, right? And I'm just going to show you all the pattern matching possibilities that you can have on sequences, right? So the first one is an empty sequence, right? So this one is going to be empty, right? So if we give it if we're gonna do show sequence like this, right, or sequence dot empty, we can just do empty. I think we have to. Oh yeah, we can. All right. So it's gonna recognize that it's an empty of any, right? But we can also do int, for example, right, and it matches. Okay. So the next one we're gonna do is the one that matches a sequence with only one element. So this is basically the last element, and we're just gonna do, I don't know, last, and so it's not gonna match this one, right? Because there has to be an element, right? So let me comment this out, and let me do show sequence was one element like this. Then we can also do 2, right? So let me just do this. So it's going to be second to last. Doesn't really matter what we do on the right hand side. The thing is that this one is not going to match, right? So we actually need let me comment this out. We actually need 2 elements, right? Like this, exactly 2 elements. The next one that we're going to talk about is the full match, right? So if you just do case, sequence, and then you say, okay, this has to be, 1, 2, 3, right? So I don't know, let's say matched. So this one is not going to match, obviously, right? But if we duplicate it and we have a 3 over here, then it's going to match. Okay, this one matched. The next one is going to be the sort of the wildcard pattern. So when I'm going to have this one, we're going to have a case over here, and we're going to say sequence of, right? So this is going to be a bit complicated. So this is going to be a first element, right? And after that, it doesn't matter how many elements we have. So it's not just a wildcard, right? Because wildcards would be the same as this one, but we won't be able to access it on the right hand side. It's a very special one. It's this one. It basically means all the other elements, right? So all the other elements. Okay, so is this one going to match? Yeah, it will. So let's try this one. Yes, this one matches. This one probably doesn't, right? Because it's empty. And this one says there has to be at least one element, right? So basically this means at least one element. So the first one, the first one's not going to match, but this one will. All of them will match. And you can just keep going like this, right? So for example, you could say, first, second, right? Second, and you're going to say, okay, at least 2 element, right? So this one is not going to match now. This one also is not going to match, right? So both of these are not going to match, but as soon as you have 2 elements, then it's going to match, right? So this one matches and this one matches as well, right? And as always, you can give them a name as well, right? So you can comment this out. You can say others or something like this, add this thing, and now we can show others, for example. Others. Oh, sorry, not like this. Others. Come on, there we go. Okay, so now we'll see. Okay, the in this case the others was an empty list, but in this case the others was this. So we can do 4, 5, like this. 3, 4, 5. Then this is basically the rest. Sometimes it's also called a tail. Okay, so this is basically all the kinds of patterns. The one thing that you need to know is a concept of called type erasure. So it's basically a long story, but the JVM has its own type system, and the JVM did not have so-called type parameters or generics for a very long time. So basically, when you're compiling things, type parameters exist, but as soon as it reaches the JVM, they don't exist anymore, right? So they're getting erased. This is a so-called type erasure model for generics, right? So basically what I'm telling you is that at runtime, the JVM cannot distinguish a list of strings to a list of ints. Now let me actually show you this. So over here, we're gonna say print line sequence empty string equals sequence empty end, and it's going to say true. And it's happening because a sequence of ints, for example, let me actually do strings over here on this side. String of 1 dot get class is the same as a sequence of an integer dot get class, right? It's exactly the same class, right? Now don't get confused, right? So if you actually compare this, right, sequence of a string to a sequence of an integer, right, it's still smart enough to say false, right, because there's an implementation that will go through the elements and compare them to each other, right? So this is not what's happening. But because pattern matching is just a fancy syntactic sugar on top of the calls to the double equals symbol or to the equals method, which is the same thing in Scala, then you can't use something like this in your pattern matches, right? So if you do something like this over here, so instead of that, if you do the type pattern, right, if you do is this a sequence of string, right, and then do whatever, right? So let's remove all of that. Actually, let's not remove that. Let's do this. So over here, is this a sequence of string? It's going to say yes, right? It's going to say yes. It matched it, right? So it says non-variable type argument string in type pattern sequence of string was the underlined type of sequence string is unchecked since it is eliminated by erasure. So there are a couple of ways to get rid of this warning, but there is no way to get to get this matching behavior, right? So you can get rid of the warning by just using whatever you want over here, right? So as soon as it becomes lowercase, it becomes a variable pattern. In fact, in some very, very complicated pattern matches, you can actually make sure that, if you have, like, for example, 2 tuples and they have like some pattern matches, at least you can make sure that it's the same type, right? So you can do whatever you want here, and you can also use an underscore. It's also common just to say string here, but a lowercase string, right? So there's a very, very easy way to get around this by just by putting your sequence into a tiny case class, right? So you can have final case class, and you're gonna call it my favorite strings, right? And what it's gonna get is your favorite strings, right? Which is a sequence of string, right? And you can even extend any val, and then it will become very efficient, right? Because any val means that the instance of my favorite strings is not going to be created, which is more efficient. So because this is basically just a wrapper for this sequence, right? So now what you need to do here is to say my favorite strings, and you need to pass it the sequence of strings, right? In this case, like that, okay? And now over here, you don't need to pattern match on the type, right? You just don't need to. You can just say it's enough to say my favorite strings, right? Because the compiler will make sure over here that you won't be able to pass in a sequence of ints over here, right? So over here, it's basically already sure, right? So you can use, for example, wrapper, and over here you can say wrapper dot strings, right? Like this thing. Okay, so now it's going to work without any warnings. But if you have an integer over here, it's not going to compile. But it's not going to compile over here. It's not going to compile over here, right? It's a very, very simple pattern, super, super useful. Okay, there are only two things left that I want to show you. The first one is how you can match on sort of two patterns at the same time. So what you can do is, so let me get rid of this, right? And get rid of all of that. Sorry, like that, okay? So what you can do is you can say case, and then you can say, is this an integer? Or, and this is the new thing, or is this a string? And then you can say works, right? So this has nothing to do with collections anymore, right? So we can show one, it works, and we can show one as a string, and it also works. And what you can do is also you can bind it to a variable, right? So maybe let me do this, right? Sorry, I'll comment out this one. So you can surround them with parentheses like this. Like this, and you can give them a name at, and you can see the name over here, name, okay, over here, right? In fact, let's do a name get class just for fun, right? So in the first one, it's an integer, and in the other one, it is actually a string. In fact, I just remember that this is I think this was my very, very first question that I answered on Stack Overflow, which is a question and answer site for programmers, and I think I'm going to put the link to this video to into that question. I just realized that if I do that in the future, you might be someone who clicked on that link. Whoa, that's like Inception. That's crazy. So if you're new here, subscribe if you want to improve the developer inside you. All right, the last thing that we're going to talk about is how to get rid of exhaustiveness check warnings. So we learned in a few videos ago, I don't actually remember in which one, that if you have a sealed abstract class or a sealed trait, like for example a color, right, then you can have a bunch of objects there or classes, sense color, like this one, and there's a type of object right here. So we're gonna have yellow, and we're gonna have green over here, right? So now if we don't pattern match on any anymore, right? So if the compiler knows that what you want to pattern match on is color, right? So for example, if we're going to say case yellow, all good over here, right? So now if we actually show, actually it doesn't really matter. We're actually not even going to show anything, right? So if we do this, then what's happening? Oh yeah, we need to change this one as well. Color, right? All right, so now you get this match may not be exhaustive thing, right? It says it would fail on the following input. It would fail on green, right? So because it's sealed, you're forced to provide all the implementations of color in the same compilation unit, and therefore Scala can check if you pattern matched on all of them or not. And it's a warning and not an error, because sometimes, you know, you might have layers of logic, and in some layer you made sure that the green color is not going to be passed in. Therefore, you don't actually need to pattern match on it. There's a way to turn it off, and the way is over here. You surround input with parentheses, and then you have a colon, and then you have an at, and this is an annotation called unchecked. Right now, the warning is going to go away. Usually, you probably shouldn't have this, but you know, you never know. Scala compiler cannot be sure that this is actually an error and not a warning. All right, now we're by the end of this video. As always, remember, pattern matching is an awesome feature, but it's just a tool. Make sure that you have a use case for it before you use it, okay? And before you tell everyone about it, how awesome Scala is, and because it has pattern matching, okay? And that's all I have for you today. We're still gonna have at least 2 more videos about pattern matching in total. And yeah, don't forget to click the like button if you actually liked the video, and subscribe if you want to improve the developer inside you. And most importantly, take care.